Ok, donc je laisse José Corral de Skapánê introduire sa partie. Merci José.
Hello, good afternoon to everybody. I've been asked to have a meeting in English, so I'll proceed so. So let me first introduce the company. I founded it 3 years ago, which is called Skapánê, as you can see on the slide. So Skapánê is a startup which is active in what we call big data and machine learning. And what I'll do for the next 20 to 30 minutes is trying to explain exactly what we do, what we intend to do with these activities, in order for you to understand the demo presented by Maxime, which will explain to you how we are going to use big data and machine learning functional algorithms being empowered and empowering deep tech solutions like the OpenIO one. So just I can't resist to the pleasure of telling you that I've been in a hurry to present this, to make this presentation, because we just closed yesterday our first round of funding, and to be honest, it has been quite a difficult period of time. So the company, so Skapánê is alive for 3 years. We are today 13 people. We have been rewarded some good stuff from French Tech or some entrepreneurship networks like Réseau Entreprendre or LM Innovation. We are at the moment accelerated by Euro Technologies and by the Innov and Connect structure from BNPP. So just have a look to the team. So we had this picture taken yesterday. To be honest, after the closing yesterday evening, we had a drink together. So as you can see, we are a team which is a balance between experienced people and youngsters. So let's dig into the subject. I know that a lot of companies are active in our area, big data, machine learning. So what we call in Skapánê big data and machine learning is the combination of data processing at huge volumes, which allows to train powerful algorithms thanks to the learning part of such technology. So what kind of usages can we build with that? So I've tried to put some of them on this slide. So there are well-established functionalities which are used in several large applications, like to predict a category. Of course, for new unknown data, it's the principle of such algorithms. I'll be training an algorithm which afterwards will be used to produce some new information, to add value, to add information to new unknown data. So second kind of usages of these algorithms is to get information, what I've called here extract attributes for new unknown data. It can be, for example, processing text, natural language processing, can be product technical sheets, in order to automatically get attributes, get information from data which is not structured upfront. I've mentioned the text processing part. I have several examples just afterwards. I'll go deeper a bit on that. We also go to image processing to automatically add value, to recognize objects on pictures, on a medical area, to be able to predict, to make some diagnosis, for example, on images. And of course, text, images, and going forward, the idea is to extend that also to any kind of data, including video, of course. So what's the topic? What is the issue there? So what we try to do is what I've called here big data for real time. I'm using the big data wording, but take it as equivalent as machine learning, as the claim we have today is big data main stake is to empower machine learning algorithms. So what I mean with real time is here I believe where is the value of such things. You've probably heard of approaches like data-driven companies, data-driven products, and I am 100% sure that the data-driven product, the data-driven company story relies on the ability to use algorithms real-time to change the user experience, to add processing capabilities as soon as we get the data, and so on. It's something on which really at Skapánê we are pushing strongly, because it's here where is the value of data-driven companies and products. So of course, in order to deploy such things, such powerful algorithms, which, to be honest, one of the main drawbacks is that most of the time we don't really understand how they work. If you are a mathematician, you can demonstrate that the algorithms are valid. That's not a problem. But to understand, to explain how the algorithm will work, how it will get some information, it's more and more difficult due to the power, the richness we put on such algorithms. Therefore, in order to deploy such technology, we need to take care about tools which we are putting around, which allow the users to monitor and to be sure about what's happening with such systems. And it's a very important feature in such applications. And of course, the idea is using such powerful algorithms, so-called machine learning, to enhance and to add value, to add features to the application we are managing. So just a specific point about what's machine learning principles. Maybe the picture could be better quality. So the idea is not, of course, to have a course about machine learning, but just to highlight one specific point. Machine learning relies on a so-called training phase in order to avoid people, humans, developers, business analysts to decide and to define rules which will be used by the system real time. The point about machine learning is to have self-training algorithms. So this relies, and we are able to build very strong machine learning algorithms when we have enough data upfront in order to train the algorithm. This is the key of such stories. And what I'd like to do for today is just to split the topic of machine learning in these two parts. One, which is the learning phase, the training phase, which has been drawn on this picture. So if you get enough money and data, and if you process, I'm thinking about the money I got yesterday, sorry. So if you get enough data and process enough data upfront during training, during learning phase, then you are able to build very strong algorithms capable of doing a very, very good job on the subject they are dedicated to. It's the key success factor to use machine learning is the amount of data we are able to process during the learning phase, during the training phase. And then, which is the point of deployment, when the algorithm is trained, when you have something which has learned about experience, about data, then the point is to use this algorithm, and as much as possible, it's what we push on real-time applications in the transaction processing, in the business processes. This is where the value of algorithm built will then deploy its functionalities to the world system. So the two parts of machine learning job are very important, and to be honest, they are quite different. The training phase, the learning phase, is where we need data scientists, where mathematics are quite important in order to build good algorithms. And then the deployment phase, when we are using the developed algorithm, is a technical story. You need to integrate deeply. Performance are key. Ability to distribute computing in order to use this algorithm along the capture of a collection of data is a key for these stories. So about the algorithms, of course, I will not explain the kind of algorithms we are using, but the message here is that we do have very powerful algorithms. Unfortunately, there is no one-size-fits-all answer for machine learning, and most of the time, job of data scientist is to compare the existing algorithms and to choose the best one to tune it. Of course, I'm sure you all heard about neural networks, but we have plenty of them which are quite powerful. Random forest, support vector machines, and so on and so forth. And building the algorithm, training it, can be quite tricky. And be sure that, depending on the subject, the best possible algorithm will be different from one application to another one. About deployment, and I'm only focusing on business view. Deployment here means business deployment, business follow-up, business monitoring about what the algorithm will do. So we do deploy such algorithms with other technical tools, which allow, as I've already mentioned, even if it's difficult to really understand and to describe how the algorithm will process the data, how he will do his job. Of course, we need to follow up and to control what's happening. So in order to tune it, most of the time, depending on the usages, you need to retrain at least partly the algorithm. And then, of course, to monitor, as I've already mentioned. Okay, so just some customers we already got. The point is not to describe all of them, of course, but just to underline that it's really state-of-the-art to deploy such technologies on a real application, which allowed us to convince some large customers, even being a small company just started less than 3 years ago. So I will finish with some real usages, some business cases we have. So, and of course, you'll see the link with ability to process that in storage and processing systems like OpenIO 1. So one concrete example, what we call the automatic mail tagging. The idea was to design an algorithm able to predict, what we call predict in machine learning, means compute real time. So able to predict the main topic of an email sent by a customer. And on top of that, to make some sentiment analysis, to try to identify the mood of the sender, of the customer. So we've done that for a customer. The idea is to, when receiving an email, a company will be able to enrich the email to add the topic and the mood of the customer. For example, in order to manage priority. The mail of a customer asking for a quote and being in a bad mood could be more prioritized than another one. This will also allow to identify unsatisfied customers, which of course is a very important topic for every company, and to route mails directly to the right department, to the right people. So this is something which is live, which is running. Something close to that is the automatic processing of documents. So it's close to mails, but the business process could be a bit different. It could be as when an employee or somebody in the company is creating a new document and putting it in a central repository or at least in a managed environment. Depending on the document types, so I've mentioned some of them here, we could use such algorithms to enrich and to automatically do some computation. So I've mentioned some real cases here. We are managing salary sheets, account statements from customers, and things like that. So other topics are possible. We've already done some summaries, automatic summaries about customers' questionnaires. Several companies, for example, once a year, will go to customers and ask them to write down what are the best things you think about us and the worst things you think about us. We are processing that automatically with such algorithms and making summaries for the customers. In order to introduce the following part managed by Maxime, I'll finish with images. There are also a lot of things to do in images processing. So I've mentioned biotechnologies. We are working with 2 companies active in biotech in order to make automatic diagnosis of diseases based on medical images, medical pictures. We are willing to set up a system to recognize automatically objects, typically vehicles taken from satellites for some public entities. There are a lot of things we can do to enrich, to add information in such formats like pictures. And we strongly believe that, again, that the value is in being able to process that when the information is captured, when the data gets inside the repository of a company. So if you have questions afterwards, I will, of course, answer with pleasure. But now I'll hand over to Maxime, which will demonstrate the kind of usages in linking such technologies, machine learning, in this case deep learning, with the storage and processing solutions.
Well, so this morning, Julien talked about the GridPerhaps, which is an API that allows us to run some scripts or command line directly in the storage nodes. And I will show you how you can use this API to deploy some containers, Docker containers, directly on the storage node and run TensorFlow pre-trained neural network to recognize some object directly within an image. So what the script will do is that it will download the file, try to recognize some object inside, enrich the metadata of the object, and then index it in an Elasticsearch. So this is just the presentation of how it works in real life. And I will show you. So I got 3 nodes, with which is the basic for the minimum required for an OpenIO cluster. And I got the GridPerhaps running on it. I will show you. I've just run 3 different tasks. So this is the GridPerhaps API. Oh, sorry, but I think it's a bit cut on. So okay. So this is the API. I can list all the tasks that are running on the different nodes. You can see that those tasks are quite old, but they are running a script that is called G4A detect object.py on each node. And then I will use just the same thing as this morning to upload some file on it. Okay. Okay, so this is stored inside OpenIO, and directly it will run. It will generate events, and those events are going to be treated directly and compute directly within the GridPerhaps application. I will show you something, the running process, maybe. Sorry. So you can contact directly the agent on each node and get the logs of the task. So that you can see the evolution. I will just reload it, and as you can see, it has detected some object inside the different pictures, enriched the metadata, and well, this application just lists those metas, but you can find it directly on the object store by running a show. If you list all the metadata on the object, you will see that everything has been. So you can see here the different categories, etc. So this process has been run directly on those three nodes, directly where the data is stored, and using containers. This is just a demo to show you that we can use some prediction, some really high-level application within the GridPerhaps, but we can do little stuff too. As we got a lot of data, the next step would be to use the data we store to train directly the neural networks. But for now, we only use it as to process new data. This is it for me. Do you have any question on the GridPerhaps, on I don't know how it works? As we index it, we can search directly. Yes?
So the GridPerhaps runs directly where the storage is. It doesn't fetch this data from somewhere else. It runs another node.
You can imagine something like that. But the philosophy is that you run where you got some resources unexploited. So as OpenIO is a very light stack, we do not use a lot of CPU resources, so it's wasted. The principle is to.
Yeah, about fetching the data locally. So the thing is, depending on the storage policy, you don't have a single location for the data. So if you use erasure coding, so the data is on 6 different servers at the same time. So you need to fetch all this data. Yeah, you need to fetch it. So I mean, you fetch it from inside the cluster, which is faster from an external gateway or something. So you use the native APIs if you want, but actually you can also use the S3 API or Swift API or whatever you want. The idea is if you run it inside your cluster, you have the best performance possible. Yeah, because it's just most of the time local inputs or inside the same rack or something. Do you have any questions about how we did it and how you could run something different? En français aussi, ça marche? No, we're good. So, thank you very much.
So let's continue for the second part. You got a second part of no, it's okay. So this is it. This is it for us.